This is the video for Lesson 6-4, Similar and Congruent Figures. Now you already have these definitions on your worksheet, so let's go over them real quick. Similar figures are two figures that have the same shape, but not necessarily the same size. So same shape, but not the same size. I'm going to jump down to congruent figures for a second. Congruent figures have the same shape and the same size. They are exactly the same. Now you'll see that they may be rotated in a way, but they are the same shape and the same size. And finally, corresponding parts are sides or angles that have the same relative position. Okay, so some properties of similar figures. Now, if you'll notice here, the way this is read is that triangle ABC is similar to triangle DEF. And our little note on the side says, when naming similar figures, list the letters of the corresponding vertices, which is the corresponding angles, in the same order. Okay, for the diagram over here, we don't want to say triangle CBA is similar to EFD because the C needs to match up with the F, the B needs to match up with the E, and so on. Okay, so once again, triangle ABC is similar to triangle DEF. And there's two things that happen with similar figures. The first is that the corresponding angles, the angles that match up in our diagrams, are congruent. Okay, those angles are the same. So over here, angle A corresponds to angle D. We'll notice that because the A is first and the D is first. Okay, the names are going to be very important. So the A is first and the D is first, so the A is congruent to angle D. Now, angle B is second and angle E is second. So that means that B and E are corresponding angles, which means that angle B is congruent to angle E. And finally, we have C and F, which means they correspond. Okay, so angle C is congruent to angle F. Okay, so the letters match up in the names with their corresponding parts. Now the angles are congruent. However, the corresponding sides are not congruent in similar figures. Okay, so here, the ratios of the lengths of the corresponding sides are equal. So if we take the corresponding sides and create ratios out of them, we'll get the same for each pair. Okay, so if we look here, AB, that matches up with ED. So if we said 5/10, okay, we'd get 1/2. Okay, let's do BC, which is up here, and EF. We have 3 and 6. So if we take the ratio, 3/6 still equals 1/2. Okay, now AC and DF would be 4/8, which still equals 1/2. Notice I'm always starting with the smaller triangle and then putting the bigger rectangle in the denominator. Okay, so once again, corresponding angles are equal. Okay, but the corresponding sides, if you take the ratio of the sides are all equal. Okay, next page. So we have two triangles. It tells us that triangle XYZ is similar to triangle UVW. We want to name the corresponding angles and the corresponding sides. So we're just listing some information here. Okay, now we could go by diagrams. However, that can be tricky sometimes. Sometimes the picture might be flipped. Sometimes the picture might be rotated. So I find it's best to just use the names to help us. Okay, so for corresponding angles, we said that the angles match up in our name. So X corresponds with U. So we're going to say angle X and angle U. That's how we name it, angle X. The next one would be Y and V. So we're going to say angle Y and angle V. And then finally we have Z and W. So angle Z matches up with angle W. Okay, now I'm going to go ahead and erase this for a second. So for our corresponding sides, we're just going to pair up our letters and make sure we do the same corresponding letters in the other name. So we have XY and UV. So we're going to say XY, and when we're naming the sides, we put a little line segment on top. So that means the name of XY. And we said that that matches up with with segment UV. Now we also have YZ and VW. So segment YZ and segment VW. And keep in mind, guys, you can name this either way. You can say VW or WV. And finally, the last one, it's going to look a little weird, but we have to say XZ. I'm going to erase this once again so you can see. We can say XZ and UW. So XZ and UW. Okay, so we just paired each part of the triangle up with another letter and took all available pairs. Okay, so I want you to try the checkpoint. Okay, use the name to help. Just like up here, you're going to list the corresponding angles and the corresponding sides. So pause the video, and when you're ready, hit play again. Okay, for checkpoint 1, we have angle S matching up with angle W. T is with X. U is with Y. Oops. And V is with Z. So if I'm going to write that down, we're going to say angle S and angle W, angle T and angle X, angle U and angle Y, angle V, and angle Z. Okay? So now our segments, we're going to say ST and WX. We have TU and XY. We have UV and YZ. And finally we have SV and WZ. Okay, example 2. Finding the ratio of corresponding side lengths. So we're given, here it's a quadrilateral, ABCD is similar to QRST. Find the ratio of the lengths of the corresponding sides of ABCD to QRST. Now notice they're specifying that the ABCD is going to come first. So when we start creating our ratio, we need to choose a side from ABCD first and then choose its corresponding side in QRST. So it says they're choosing in this one as an example AD, and if we look here, AD would correspond to QT. So that's where the QT came from. So the length of AD is 8. The length of QT is 10. And then you would just simplify it. So it's 4 to 5. So the ratio of the lengths of the corresponding sides is 4 to 5. Now our note on the side says because all the ratios of the lengths of corresponding sides of the figure in example 2 are equal, you can use any pair of corresponding sides to write the ratio. So instead of saying AD and QT, we could have said, let's try, we'll do BC and RS, just because those don't involve decimals. So BC and RS would still be 8 over 10, and we still get 4/5. We could have done AB over QR or DC over TS, and those ratios will also equal 4/5. Okay, try checkpoint 2 using the same ideas that we just did. It's telling you that FGHJ is similar to KLMN, and you're finding the ratio of the first one to the second one. So press pause, find your ratio, it should be pretty quick, and then hit play again. Okay, for my example, I'm going to use FG and KL. So we're going to set up a ratio. The FGHJ one comes first, so FG over KL. It's often good to tell me what segments or what sides you're using. In case you make a mistake, I can give you partial credit. So FG is right here, so that's 8, and KL is 6. So our ratio, if we simplify it, would be 4:3. Now remember, you could have chosen other sides. I'll do in one more example, HJ and MN. So HJ and MN. HJ is 20, MN is 15, and if we divide both by 5, we still get 4/3. Okay. Example 3, finding measures of congruent figures. Now this symbol here, the equal sign with the squiggly on top, means congruent. So this is saying DEFG is congruent to KLMN. And we need to find the measure that they give. Okay, now in congruent figures, all the corresponding angles are congruent and the corresponding sides are congruent. So if we're trying to find the measure of KL, okay, when they don't have that segment bar on top, it means the measure of KL. So we're going to say that using our names, KL corresponds to DE. So down here, segment KL is congruent to segment, segment DE, which means the measure of KL equals the measure of DE. Okay, when there's no segment bar on top, it means measure. Here is DE. Its measurement is 8, which means that KL is also going to have a measurement of 8 feet. Okay, angle L matches up with angle E. So down here, angle L is congruent to angle E. And this here means measure of angle L. You might want to write that down. When you have the M with the angle, it's the measure of the angle L. So we're going to say that that equals the measure of angle E. Angle E is right here, which is 111 degrees. So the measure of angle L is 111 degrees. Okay, last checkpoint. So give it a try. Once again, should be fairly quick. Pause your video, and when you're ready, hit play. Okay, in example 3, it says that triangle ABC is congruent to triangle LMK. We want the measure of angle L. Well, angle L is the first letter in that triangle's name, which means it's going to correspond to the first letter in the other triangle's name, which is angle A. And angle A is 58 degrees, so the measure of angle L is also 58 degrees. Okay, so just to recap real quick. We have similar figures. Oops. And we have congruent figures. Okay. Now I'm going to start with congruent figures. So for congruent figures, I'm going to abbreviate. Corresponding angles are congruent, and corresponding sides are congruent. Now in similar figures, just like in congruent figures, the corresponding angles are congruent, okay, but the corresponding sides are different. Okay, and the important thing was that the ratio of the sides of one figure to the other are equal. So the sides aren't equal, but the ratios of the sides is equal in similar figures. Okay, so if you had any questions, please make sure you jot them down. Remember, using the names of your figures is very important. Okay, matching it up letter for letter. Okay, and we will practice this tomorrow in class.